solution. Sometimes it's so dilute, it's actually harmless and it's not even illegal. But if it's a high concentration, it's dangerous and it is illegal. So we have to know that too. We not only have to know what it is, we have to know how much is there. So the quantitative analysis is important. This is true for how much gets sold, meaning this. If we know how much there is, this can tell us about the crime scene. Now, if we find only a tiny amount, then it's not necessarily likely that this is a place where they sell it, because if they sell it, they probably have a lot in their, a lot to sell, a lot in their storage, so that they can sell a lot. If they just use it, you just want to use a little bit and that's it. But if you want to sell it, you want to have a lot in your inventory. So if there's a lot of the stuff, let's say it's extremely highly concentrated, they must be, maybe they're selling, they're giving milliliter by milliliter, but they're going to sell it. So if it's highly concentrated, let's say, or there's a lot of it, we might want to examine who else came to that vicinity. Maybe they took the drugs too, and maybe they also have the drugs. Or we want to know who got there to deliver it. Maybe we can trace the source of these drugs. Or maybe, if there's a lot of it, the location where they manufacture it is nearby. So start checking the sheds and maybe hidden rooms nearby where they might manufacture it or contain more and more of it. If it's just a tiny amount, that's probably just the user, and you don't really have to look for that. But if there's a lot of it, this might give more information as to what else is going on and what other crimes are going on. So that's another reason to make sure you know how much there is, and not only what it is. So there are some simple color tests, the initial tests. That's what to do. Let's say to perform more investigations. The simple color test will tell, that's LSD. If so, where's it coming from? If it's, let's say, marijuana, you might not need to know how far away it came from, because you can grow marijuana a lot of places. So it might not be, again, initial information from these simple color tests. They can tell you which direction to go when you do further investigations and further detective work. So this is used for initial screening. They're not, you need to confirm them, and they're quick. That's why they're used. Simple, easy to use. They're sold commercially as a kit. So instead of going to the lab and putting all the chemicals together and then seeing, it's purple, that it must be this drug, then it's a commercial kit where they sell 20 of them. It's a little plastic bag and a little plastic container. You tear it open, drop the mysterious powder in there, turns blue, and there you go. You know what your test is. Instead of going to the lab and combining all the chemicals into one beaker and then putting it in. It's already sold, everything all combined. There are 5 of these simple basic color tests to know about. The Marquis, the Dile Capagni, the Ducournau-Levine, Van Eyck, and Scott tests. Sometimes the test doesn't require just one. Sometimes it requires 2 steps, putting one reagent in, then another, and then seeing, now I know what it is. Anyway, there are these kits. Here's the Marquis that tests for heroin, morphine, various opiates. Fentanyl will also show up when you put it in. It'll turn purple. That's what you see here. This is the Marquis reagent. You unzip this thing, I think, or tear it open. Drop your stuff in there. If it turns purple, you might start it as orange, but if it turns purple, then you know. Then it's that it's morphine. Ecstasy will actually turn black, but it's not. I don't think it's specifically used for that. But if you happen to not know it, but you might have a different test for ecstasy. But ecstasy, that being hallucinogen, I think. So anyway, it's made really for opiates. And morphine will turn purple. Methamphetamines it also tests for those, even though it's not specifically designed for that. It'll turn brown, so it can actually test for 3 different possibilities at the same time. If you do it and it turns accidentally brown, so it's an amphetamine. But really, it's made mainly for opiates. If it turns purple, you got an opiate in there. We have this one for barbiturates. This is, it takes formaldehyde and sulfuric acid, dilute sulfuric acid, I think, turning purple. The barbiturates use cobalt diacetate. In methanol, this requires also, you also have to add your isopropylamine, also in the methanol. And if it's a barbiturate, it'll turn purple. So again, that's another thing. You drop it in there, this will turn purple because it's got all that stuff in it. That's a test for barbiturates. For marijuana specifically, it's hallucinogen, but it's for marijuana. We have this acetaldehyde, in the vanillin acetaldehyde in ethyl alcohol. Then you add the hydrochloric acid, and then you also have to add this thing. It's chloroform. It's a liquid chloroform. You take some suspect vegetation like the flowers or some green stuff that you find and you suspect it's marijuana. You put it in there, and you will develop two different layers. For some reason, the chloroform layer is on the bottom, and the watery layer is at the top. And if you have the purple color mainly or almost entirely in the chloroform layer, that is a sign of marijuana. And you can even see how the test goes here. It's the whatever it is, the Duquesnoy-Levine. Whatever it is, I can't read that word there, but that's what it says. Again, you put it in there, turns purple, but then you add the chloroform layer, and then you'll see it gets to the bottom. That's the real purple, and slightly purple on top. Sure enough, that's what this test tested for, and this was marijuana. We have for LSD, that's a simple one. You just put the paradigmethylamino benzaldehyde in there. There are two methyls on the amine group there. It's in water, in a HCl solution in water mixed with methanol. If it turns purple, you have LSD. Now, LSD, even a tiny amount of it is what people use, so it might not always catch this. So you would need a confirmatory test. We also have a Scott test that's specifically for cocaine. Again, two different liquids here. You have the cobalt dithiocyanate. It's in a 1-to-1 mixture of water and glycerin. Then you have to add hydrochloric acid, and then you have your chloroform, your liquid chloroform in there, and that will form two different layers. What first happens is that it'll turns blue. Then you add the HCl, it'll turn pink, but that's not enough because I guess other things will do that. You put your chloroform in there, your liquid chloroform is in there, and it'll actually separate. There's blue in this chloroform layer over here, then and pink in the rest of it because that didn't change. Then you have cocaine. Now, these are like quick, simple tests. They're useful in a courtroom, but they don't prove conclusively. What you need is a secondary test. Now, microcrystalline tests, they can be done by themselves, but they can also be added to the original test as a confirmatory test. So, microcrystalline is when you make crystals. You precipitate certain things as crystals, and they form needle shapes. Long needles. They form like the short ones, or they form small, just crystalline, meaning tiny little crystals without any deliberate shape. I guess squarish. I guess cubic, sort of diamond cubic shape. Again, the different shapes of the crystals can be seen in a microscope. So you add the thing that precipitates it, and when you do that, it will precipitate as a crystal, and you can check the shape of